screen. All right, can you see this?
We can, yes.
All right. So welcome everyone to this workshop. We're going to be talking about data analysis with Pandas and Matplotlib. My name is David Yanio. I am the artificial intelligence lead at Google Developer Student Clubs. We're a club here at FIU trying to nurture the Google developer community. We have multiple communities. As I said, I'm the lead for the artificial intelligence community, but there's also communities for mobile development, interview training, and as well as web development. There's also a game development community for the gamers out there. So with that said, let's begin. So the agenda for today, we're going to be looking at code notebooks, which is what we're going to be using to actually use Pandas and Matplotlib. We're going to be looking at what is Pandas, what is Matplotlib. We're going to be working with data using Pandas, and then we're going to be plotting out some of that data using Matplotlib, and then we'll conclude the workshop. So what are code notebooks? So there's the standard definition. They're documents that contain a mix of rich markdown, executable code snippets, and accompanying rich output. So these are all separated into distinct cells and can be interleaved in any order. So the difference between a code notebook and the regular scripts you're used to seeing is that if you look at over here or in the link we sent in the chat, that goes to Google Colab, the code is in these little blocks instead of a giant script file. And these blocks, they can be executed in any order and, well, have the output right there. So there's usually two that I recommend. I don't know if you guys have heard of Jupyter. The Jupyter Notebooks is the code notebook software for your local machine. That usually comes with Anaconda. I don't know if any of your professors have asked you to install that before. I wouldn't recommend it, but if you have it. And Google Colab is the online version of a code notebook. It's hosted by Google. So they also have some GPUs that you can use for your data analysis. So what is Pandas? Straight from the website, Pandas is a Python package providing fast, flexible, and expressive data structures designed to make working with relational or labeled data both easy and intuitive. Relational and labeled data, what this means is basically table data. As you see here, this is a Pandas data frame, one of the fundamental data structures in Pandas. And you can probably tell that it looks a lot like an Excel sheet. And that's what they mean when they say relational data. They mean like a table like this. So what is Matplotlib? Matplotlib is a comprehensive library for creating static, animated, and interactive visualizations in Python. So there's actually a couple extensions that Pandas has that uses Matplotlib. So you don't have to necessarily have them both at the same time. You can use Matplotlib through Pandas, but we can do it separate if we want to. And here are some of the basic graphs that they offer. So working with data using Pandas, I'll get to the notebook in a second, but let me first give an overview of what we're going to be doing. So there's two structures. Two data structures. There's a data frame, which is the table that I showed before, and a series. And a series is like the same thing as a data frame, but it's only one column, and that's it. That's the only difference. There's a couple functions: head, describe, lock, and iLock, apply, read CSV. These are very common functions, but there's more that I'll show in the notebook. And some of the applications for Pandas is viewing data, selecting data from your massive data, your modification, grouping, all types of applications. And plotting with Matplotlib. So here I list some of the various graphs that they offer. The basic, you saw this in the picture before, align, scatter, bar graphs. For arrays and fields, it's more like a specialized type of graphs. So I'm not going to be going over it in this one, but MShow, contour, and stream plots. MShow in particular, this can make an array and show it. This is useful for pictures because, you know, you can represent a picture as an array of pixel values from 0 to 255. So you can actually plot that out and you can show the picture. It's useful for computer vision if you go into a machine learning. And there's also some statistics plots like a histogram, box and whisker plots, and pie charts. All right, let me actually go to the notebook now. So this is probably what you're going to be seeing if you went through the link. If you can't already run it, you can go to File and save a copy in your drive and then open it, or you can download it and run this notebook locally, or there's a button right here where you can also copy it to the drive. So regarding the data that I'm going to be using. So I actually went to Kaggle. This is a data science competition website, but people also upload a bunch of data here and their notebooks and discuss data science. So this is one of these data sets. It's an Amazon product data set. It has a couple of products with the reviews and their dimensions and basically a description. It's something you would get off an API from Amazon, and that's why I chose it. This is a very real example of data you might be working with. So let me actually send that in the chat as well. So you can go ahead and download this data. So when you first open the page, you're going to see this. You scroll down and you go to this 7817 CSV. You download it. It's going to download as a zip file. You unzip it, and then you can go to your notebook. You can go to this folder icon here and upload your file. Upload this 7817 file. I'll do it just to show how it's done. Click, go to your downloads or wherever you have it, and upload that. If you have Excel, it'll show this icon. Upload that CSV file. And keep in mind that if you close the window and you open it again, you're going to have to upload the file again. All right, there we go. All right, so any questions so far? Do you need me to backtrack? Let me know. Oh, I was inactive for too long. All right. If there are no questions, then I will begin going through this notebook.
We have a question.
How do I run?
Yeah, from Armando.
Okay, so there's two ways. Well, there's a couple ways to run these cells. So the first way, you click in the cell, you can press Shift Enter to run the code cell. Nothing else will run, just that code cell. You can do Shift Enter. You can run it through this play button right here. Or the hard way, you can go to runtime and run the focus cell. It also shows the shortcut over here. Does that answer your question? I hope so. So, all right, continuing. So let's create our first data frame. So here I have a dictionary of data. I have shoe size, a list of shoe sizes, the height, just a string for tall or short, and a basketball player, and just a bunch of Boolean values. And I can go here, make this variable called data2, and initialize my data frame using pd.dataframe and putting in my data as the data parameter. So actually, this import pandas as PD and import matplotlib.pyplot as plot. These are the standard ways of importing these into your environment, whether it be into a code notebook like this or a script file. This is the way most people do it, the agreed upon way. Right, so after we initialize that data frame with our data, we're going to use the head function to see the first 5 rows. But since I only have 5 rows of data for each of these columns, it's just going to be the entire data frame. And that's what it looks like. You can see it, it's a table, like an Excel table. You have your indices here. This is not part of the data per se. It's just an identification of each row. You have your shoe sizes, your height, and your basketball player columns, and each row. And just to show, you can also just do data2 and do it that way. And that will show the entire data set. Let's just keep it a set for now. And I'm going to be using Shift Enter, I think. This is Control Enter, but I also use Shift Enter. I'm going to be using Shift Enter. So if you don't see me pressing the play button, that's how I'm running this out. Right. So now that that's done with, let's import our data, our Amazon product data. So to do that, we need a file path. How do you get it? If you haven't already done so, you go to this folder column. Hopefully you've uploaded your data already. You can go here and copy path and paste it over here. And I'll show how that's done. It's kind of self-explanatory there. And we create our data variable where we're reading in a CSV, which is in our file path. Right? So now we've created our data frame from the CSV data that we just imported. So let's look at the top 5 rows then. Kind of large and messy, but we'll look at some of the tools that Pandas has available to make this a little cleaner. Question? I actually pressed the file with the 2 dots. How do I get out of that file? Oh, this? All right, so when you do that, you have to go to the content. Where is it? Here. And that's where your file is. Yes, so the content is the default one that you're seeing. You're welcome. Right. So we can also look at some sort of overall data about the data frame, like the columns, the index, and the shape. Keep in mind that everything in Python is an object. So what I'm getting here, when I have this dot columns, this is just a member variable of the data frame class. So here are my columns. I have I'm pretty sure 27 columns. The indices, I have 1,597 rows. And the shape of data, 1,597 rows and 27 columns. Just some overall data. You can also have this go to list to print it out as a Python list, but it does that. All right. Now, another thing we can do is look at the data types for each of the columns. And I'll show that here. So there's a couple of different data types. There's object, float, and there's also integer objects, date time objects for pandas. And these are allocated automatically if you import data. Object, what object means is it can be either a string, a list, a dictionary. Basically anything that isn't a float, an integer, or a date time, they just call it an object. Float 64, well, it's a float value, a decimal value. There's no integer values in this data frame, so you won't be seeing that here. You can also turn, in the same way I turn the columns into a list, you can turn this series into a data frame. And now you have a data frame with your output. So I'm mostly going to be going over the most common functions. So if I'm going too fast, let me know, and I can explain the function again. You can use nUnique to see the different number of unique values in each column. So in ID, there's 66 unique values, which means there's 66 values in the ID column that are different from one another. In a colors column, there's 3 values that are different from one another. And we can see the top 5 usernames. Here's how you select the column. You do data, you do bracket notation, and in a string, you put the name of the column, and then you can do functions on that column. So in this case, I'm doing value counts, which is going to count the occurrences of each name. And here, I'm indicating that I want only the top 5. So if I didn't have this :5, I would get all. But since I want the top 5, the other ones. Okay. Another useful trick that I did not include is finding all the missing values. So you go to data, is NA, something like that. And this will get all the NaN values in each column. What is a NaN value? It's basically no data for that column, or not column, but row and column. So I'll show you an example right here. NaN. This means that there's no data for that. So it's not the same as 0. it's more like void. So there's nothing there. I hope I explained that right. But let me know if I need to explain it again. Right. Describe is a function that you can use to get just statistics values on all the numerical data. So go through your entire data frame. It'll get, it'll go through your data frame, look at all the columns that have numerical data, like the float 64 columns, and then it'll get some statistics from it. So the count, mean, standard deviation, the minimum, the maximum, and 25%, 50, 70%, 75% is like in a normal distribution and what part of that normal distribution it's at.
Hey, David, we have a couple questions about the NAN in the chat.
Okay, let me go up. So I'm doing data, which is my data frame, is NA, which is finding all the NaN values or null values. And then I'm doing sum, which is going to count all those occurrences. And then that returns a series, which has the column name and the count of the NaN values. Let me know if you want me to explain that more. So if I didn't have this sum, it would just have a data frame where all the columns and rows is like, is this NaN? No. So it's gonna put false. Is this NaN? Yes. So it's gonna be true. But if I put sum, it doesn't do that. It just gets counts. Yes. Yes, NaN is the same as null. So let me see if this works. No, the Python version is not the same. But np.nan is basically the null value that they're using, NaN. Right, so where was I? Where can we find, that's for later. Counts for each column, right? Yeah. There's the column name, and this is the count of the NaN values for that column. Right, the describe, or describe the describe function. It goes through your data frame, looking for the numerical columns, and it gets some statistics data for that column. All right. So let's go ahead and do some sorting. You can use the sort values by. You can choose a column to sort your data by. I'm going to sort the data by the number of helpful ratings. If you ever went to an Amazon review, they have this is this review helpful button, and that's what that rating is. Ascending equals false. This makes sure that it's in descending order. So the most is at the top and it goes down. Put that. Now I'll show the helpful ratings here. So the most helpful reviews will be on the top and it'll go down. That's one way to sort your data. Question? Okay. You can select data using the loc function. Loc is short for locate. So here I'm locating in the data in the data frame, in the reviews.username column, the NF username. And it returns a data frame with all the rows where the username is NF. It could have been anything else. Let me get another username here. Michael S. Michael S. He has a couple. You can get all the rows where he is involved. Or it could have been any other column, to be honest. Let me go back to the num helpful rating. And I can see all the rows where the num helpful rating is more than 500. And you can see it's not really in order anymore. But I can change that. Oops. And this is in descending order. So the least number goes from least to greatest. But by putting descending equals false, we'll go from greatest to least. And that's the way, and that's the quick and easy way of locating stuff in your data. So another way is using iLoc. And what this is short for, it's short for index locate. So instead of locating by some conditional value or column, you're more locating through the index values. So for this, I'm selecting the third row. So I'm looking at index value 3, looking at the third row. I can also comment this out. I can also use it like this. Looking at the third row, only columns 4 through 6. Or I can slice the data. I can do, I want the 3rd through 5th columns, rows. And when you're doing slicing like this, you need to keep in mind that it's not including the later value. So it's only going to show 3 and 4. And you get your data like that. All right, am I going too fast? All right, let me know if you guys have any questions. All right, so this is what I showed you before, showing the isNA.sum. Let's just keep it there. And this is a good part about code notebooks. You can just skip code blocks and go to other ones. So one thing I can do now is deal with this np.nan data. It's not good to have missing data in your note or in your data frame, especially if you're doing machine learning with it. So there's 2 ways to deal with it then. One, you can drop the rows with the missing data. If if a column has too much missing data, it might be better to just delete the entire column and use the rest of the data. And in this data frame, I'm just gonna drop every row that has missing data. So if I do that and print out the shape of the data that comes out, we'll see that I have 0 rows and 27 columns. That basically means I just deleted all of my data. So every row in my data frame has some missing data in some column. So I can't do that in this case. So how about now I'm going to actually fill in the value. So I go to reviews.rating. You can select the column like this. So I'm replacing the old column with the new column with the NA values filled with 0. So if there's no data for a rating, I'll just fill it in with 0. And as you can see, I still have all my data. Does the delete the data in your or only the Python data frame you're working? No, you are only deleting the data in the data frame. So yeah, this CSV file, once you load in your CSV file into a Pandas data frame, it has nothing to do with the CSV file anymore. So you can load it in and load it in and load it in, and it won't affect the CSV file unless you export it into a CSV file, into that CSV file, and then it will change it. Right. So let me get my columns again, because now I want to drop the columns that I know are pretty useless, like the ID, ASINS, EAN keys, manufacturer number, UPC. These are all numbers that manufacturers and delivery companies use. That it's not really important to us. So we can drop these by using the drop function, specifying the columns we want to drop. In this case, I have a list here, and in place equals true. What this parameter means is I want this change to happen on the data frame. So if I didn't have this here, it would just return the data frame with the drop columns, but it wouldn't change the data. Let me actually show it. So if I do data.drop here, it would return a data frame where the columns will be dropped, yes. But if I go and get the head of my actual data, it'll show that the columns that I just dropped are still there. So why is this happening? It's because Pandas functions, they return a data frame with the function modified by the function. So it doesn't actually apply it to your actual data frame. It just returns it. One way to circumvent this is to just do data equals. So you say, okay, this data frame, the data frame that this is going to return with the drop columns, make it my data frame. Or you can do in place, and that will make sure that the changes are made on your actual data frame. And as you can see, it didn't return a data frame, so it didn't have that output. And the columns that we wanted gone are gone. Right. So this is a mess of a data, to be honest. So one thing I noticed, like just off the bat, is dimension column. And it has this string has the dimensions, length, width, and height. But I don't want it to be altogether like that in a string because it's hard to actually work with it. If you've ever worked with string value, you know that it's kind of hard to extract the numbers from a string. And if you're using your data in machine learning, your machine learning models do not like strings. So you got to turn those things into numbers. So what I'm going to do, I'm going to try to separate this dimension column into 3 other columns. So length, width, and height. So just to prove that this is a string, the D type of this column, this is another way of selecting the column, by the way, with dot notation. But you can also do the bracket notation as well. And it's the same thing. First, let's fill in all the missing values. Some are digital, so you should split. So what happened? Question? Okay. So I'm going to fill in all the missing values with 0 for everything. And do the in place equals true. So make sure that it actually does it on that column. Then I need to make a function or make a way of extracting these numbers from this string. So I'm going to just select one row and try to do it that way. So as you can see, if I do dimension.0, I'm getting the first row, the dimension from the first row in the data. I'm printing out the data type and the string itself. So one thing we can use here, I imported this before. It's the RE library. It was at the top. And this is for rejects. And what are rejects? Rejects are special strings that can represent a pattern in the data. So let me show what that means. So I'm trying to extract these numbers. So one thing I can do using rejects is get the space, the MM, the other space, the X, and the space, and I can separate the numbers like that. And that's what I'm doing here with the split. But one thing that goes wrong with that is that when I split it up, I get the first 2 numbers okay, but I don't get this MM split or taken out over here in the last value. And that's because there's no MMX and the space after that. So it doesn't recognize that doesn't need to be in there. So to prevent this, I go to the second value in that list and I should replace that space MM with nothing. Then I have my 3 values, my length, width, and height. So let's actually just create a function for this process. So I'm going to get in a string, which is going to be my dimension. I'm going to do this reject split. I'm going to replace the space MM with nothing. Then I'm going to return my length, width, and height in that order. And there's 2 functions that are being used here, the concat and apply functions. Concat is just to concatenate the columns to the end of the data frame, and apply is going to apply the function we just made to a column. So let me show how that works real quick. So let's say I want to go over here to num helpful, and I'll And I actually want everything divided by 2. So I can go over here to data.apply, and I can use lambda. Lambda x divided by 2. So what does lambda x mean? It's an inline function. That means every row that's fed in or every cell that's fed in. So a cell here would be this. So every cell that's fed in, divide by cell by 2. Oops, hold on. I meant to select that one column. Reviews no helpful. Right. And there, as you can see, it's all divided by 2. You can also apply library functions. For example, np.root. Square root, I mean. No. And you can get the square, you can root every cell in that column. And I'm pretty sure that did not apply to the actual data. Let me check. If I go over here. Helpful, yeah, it didn't apply to the actual data. But I'll keep that there for prosperity. And when I actually save this Colab notebook, it'll probably appear in your notebook. I just did that, so hopefully that appears in your notebook. So let's get back to this function. So we're applying our function to every cell in that column we chose, and we're concatenating it back into our data frame. So now we're going to apply and concat to our data, to the dimension column, our function, and it's going to return 3 columns, length, width, and height. Oh, but I get an error. So what's the problem here? So first thing I think, okay, there's probably a value in that column that my function doesn't take care of. So if I go to data.dimension or data bracket dimension and look at the unique values, I can see that, look, there's this string here that's not millimeters, but it's inches. So the regex I have here, it doesn't pick up on these inches and it doesn't split it up correctly. So what do? I'm lazy. So normally, if you're in a professional setting, you would convert the inches into millimeters and do it that way. But I just have this or sign here, so I can catch the inches, so I don't convert it. It's gonna bite me in the butt later, but it's just quick fix. I don't recommend doing that, by the way. Definitely convert it if you need to. And then I apply and concat it. And then I also drop the dimension column because we don't need it anymore. We split it up into length, width, and height. Let's get the head. And here, all the way at the end, you can see our length, width, and height columns. And we don't need that dimension column anymore. Right. So those were pretty much the most useful functions in Pandas. And with those functions, you can probably handle any data set that comes at you. There are some more advanced functions that I hope you can look into yourself. It's kind of difficult. They're kind of difficult, but once you get the hang of it, you become a Pandas master. So at this point, are there any questions regarding any of these functions or pandas in general?
Hi, Milo.
Wait, do you go to look?
Sorry, I muted you by accident. Can you
Yeah, where do you go to look for these functions that are difficult? Like, is there like a website that just has all these functions and what they do?
Yeah, so the main way to search up these functions is to go to the pandas documentation. So it's pretty easy to see, pandas documentation. It's pretty in-depth. I definitely recommend it. You can also, there's also user guides and getting started stuff. Or this is what I do whenever I want to do something with my data frame. I just look up what I want to do, and there's usually an answer on Stack Overflow with it, with the pandas function that you need for that. There's a lot of pandas function. I don't recommend memorizing all the functions that pandas has, because then you just have a bunch of functions and you're not necessarily using all of them at the same data. So it's a learn as you go type of thing. That's what I recommend, at least.
Okay, thank you.
All right. So that's plot with Matplotlib. So as I said before, pandas has built-in functions that already use Matplotlib. So you don't really need to use those libraries separately. And at least for beginners, I wouldn't recommend using the Matplotlib library separately. Why? Because it's kind of hard, not gonna lie. It's kind of hard to use and complicated. So just stick with the pandas built-in functions that extends Matplotlib. So you got that complicated stuff abstracted from you. But if you want to make more complex charts, I definitely recommend looking at the Matplotlib documentation and seeing what you can do. So here, I want to get a histogram of the helpful reviews, the helpful ratings. So let me get that. So here I'm just doing hist function, and I'm passing in the column reviews.numHelpful. So as you can see, there's a lot more unhelpful reviews than helpful reviews. This kind of skewed a lot, but you can't really tell which column is which. So what you can do, you can still use the Matplotlib to actually modify the chart. So here I'm setting the title to histogram of helpful ratings, the X label to helpful rating, and the number of reviews as to Y. And if you have like a line chart with multiple lines, you can also do a plot legend to show a legend of the different lines and what they signify. And why do I have semicolons here? Well, it doesn't really matter, but when you have a lot of Matplotlib functions back to back to back, it's kind of helpful to have the semicolon, at least in my opinion. Right. Now this is where it gets a little bit more involved. You actually have to find the data you're looking for. So for a pie plot, what I want is a pie chart of the users who have the most helpful review ratings. So I want which usernames have the most helpful reviews, and I want a pie chart of that. So I get the reviews that have more than an 800 helpful rating, and then I get only the column for the username. So here's what I have. I have a column or series with 20 rows. Basically, it's just a bunch of usernames. And I'm going to get the this is kind of I still found this on Stack Overflow. So basically what it's doing is counting the string values and putting them in a pipeline. So like that. Let me show you the series as well. Just a bunch of usernames. And here I have the pie chart, the spread of usernames. And as you can see, there's some outliers here, Michael S. and JJ CEO. They have Brian R. They have a little bit more than everyone else because they probably have 2 and everyone else has 1. So these are probably the most helpful, the usernames or users that have the most helpful reviews. Over here, you can make, I'm also showing, you can make a scatter plot. I chose the length and width columns. There's not good data, to be honest, in this data frame to make a scatter plot. So I just went with what I had. So yeah, this is the scatter plot I ended up with. And let me actually do plot title, modify the title because there's none. There, now it has a title. All right, any questions? It's getting to the end.
I have a question about the next script.
Oh, this one?
Yeah. So what does the AX equals AX mean? Because I usually see that a lot, but I never know.
Okay, so here's what it means. This is, I just put some more Matplotlib stuff here, and this is why I said it was kind of complicated. So here we're getting a figure and an ax. The figure is basically the plane where your image, where your plot is going to be. So this is basically the entire figure here. The ax are the axes. They mean axes. And you can modify stuff on that axis by using ax dot functions. So I can do ax dot ticks or something like that, x ticks, and modify it like that. But I'm not going to do that. But that's what it's saying here. Ax equals ax. So the axes of this figure are this. So it's basically assigning the axes. So the axes of this box and whisker, have it be the axes of this figure. That's what it is.
Okay, thank you.
And here it is in all its glory, the box and whisker. It's a little bit bigger than the other ones because I'm using this fixed size here. If I took this away, the titles would be overlapping, and I don't want that. And you can also do a rotation of the string values. Here the names. Here the names are kind of long, so I just rotated them 90 degrees so they all fit. Because if I rotated only like 45, it'll be kind of screwed up. See, they're not lining up with a tick. All right, another question. Can you explain the lambda cell, PD series func cell? Oh, okay. I mean, we're pretty much done. Let me go over the conclusion slide real quick, and I can go back to that. So in conclusion, you learned about pandas and Matplotlib, and you learned how to work with data using pandas and Matplotlib. Thank you very much. If you want to join the Google Developer Student Club, feel free to take a screenshot or scan the QR code on the screen. That'll take you to our link tree, and you can join the club or just hang out in the Discord, whatever you'd like. So that said, me actually post a link to the Discord because that's our main form of communication. Let me go back to the notebook and explain, because I know what you're talking about. This right here, right? Right. So what this is doing here, it's making a series. And remember, a series is a data frame with only one column. So it's making a series of the three. So it's making 3 series here. It's making 3 series based on the measurements returned from the get measures. And then it's concatenating them back into the data frame. So let me show what that looks like. And the index here is just having the index beta columns. I'll show what that looks like. Don't worry. And the workshop is over for anyone else that doesn't want to see this. But if you have any other questions, let me know. So I have this has to be the same here. I'm counting the parentheses to make sure I have them even. Be inside this function. Oh shoot, I deleted the column. So turns out I need to go back to, and this is what I was saying before, you can load in the data again. So now I have everything back to its original. Where was I? Right down here. Oops. That's- Oh man, not this error again. So one error I usually get using lambda is that it doesn't take in this axis parameter. Okay, it's not gonna work. So let me just show you on Microsoft Paint what it would look like. So it'd be it would be a square. Oh man, come on. It'd be a square with this. Well, actually, two. This is what it would be concatenating. And let me put some lines here. So it would have an index like 1 here, and it would have the length. The width. And the height. And then you have like 190 something, 68 or something like that. And like 10. And then it would go like 2, and it would basically repeat L with height and repeat. Why does it look like this? Because these rows are grouped together. So then when it's concatenated into the data frame, it kind of flips it or transposes it and puts it back. Did you delete? Yeah, I did. I actually filled it in. So yeah, that's what this axis equals 1 is doing, by the way. It's accessing the series that it returns by row instead of by column, and it concatenates it using the rows. I'll delete this. But I might want to actually uncomment this. I mean, comment this because it's for the people that want to run all the cells at the same time. All right. Any other questions? This is pretty much the end.
I do have one final question. Where could we get a copy of the recording?
So I'm pretty sure it's going to be emailed.
I will
Emailed to
email
you?
it out, and then also we put all of our workshops on something called LibTube, which is our media server for the libraries. So it'll live there as well. So I'll go ahead and email that out to folks once it's rendered from Zoom.
Thank you so much.
Yeah. Are there any other questions for David before we sign off? Well, thank you so much. Thank you for coming to the virtual Digital Scholars Studio. We're a real place too in the library. And thank you to the Google Developer Student Group for coming and doing this workshop for us. This is awesome. I know.
Thank you for hosting us.
Yeah.
And thank everyone for coming.
Yeah, I know. We had a great turnout. So thanks everyone, and everybody have a fun, restful weekend. All right.